Okay, the last one is about the factorial experiment. In this case, we have two variables that affect the dependent variable, and we want to measure which if this variable affect or this variable affect or the interaction between the two variables, how affect the real variance on your data. Okay, for this one again, I'm going to do the same example that the book has. As this is the GMAT study, and we have three different colleges and three different programs to prepare for the GMAT, and these are the GMAT scores for two people from business with this type of review or this type of program, two people from business for when they prepare with the one-day program, and 2 day for the 10-week course, and the same for engineering, arts and science. And we want to know if really college affect the GMAT score, how the program that they use to prepare for the GMAT affect, and how the interaction between the college and the program used is affecting the overall variance in this data. Okay, in order to do that, we have to go again to data analysis, and we are going to do again the two factors, because we have two variables, the college and program over here, and we have replication. Replication is because we have more than one sample for each one of the possible matches on these variables. Okay, and that's it. Hit OK, and the input range again is going to be the whole thing. Okay, how many rows per sample we have? We have 2, because we only have 2 people from each one of the elements or the colleges and programs. We do have 2. We are going to use alpha 0.05. We can change this program, it's no problem at all. And the output range, we might go, okay, put it in here. We really don't care. In this case, the ANOVA table is a little bit more complicated. Okay? This is my ANOVA table. It is because this is because of the sample, because of the columns, and this is the interaction, okay, of the two variables, and this is the error. So we now have 4 rows in here, and the total, again, if you add these numbers in here, this is the total. If you add these elements in here, this is the total. The sample is nothing but the program. We have 3 programs, and that is why we have 2 degrees of freedom. We have 3 colleges, and that is the columns, okay, or the treatments, whatever it is. So we have two variables at the same time, and this is the interaction between the 2 variables, the college and the program used to prepare for the GMAT test. Okay, the MS is exactly the same. This is sum of the square divided by the degrees of freedom. 6100 divided by 2 is 3050, and so on, so on, so on, so on. Okay, this F is equal to 3050 divided by what? The error over here. The error, the within variance, the 2205, the mean square of the sample, or the one of the variables divided by the mean square of the error. This one over here. So this 3050 divided by 2205 is 1.38. This F over here is 22,650 divided by 2205. Okay, it's 10, and this is 1.26. Okay, go to the next one and see the p-values. If the p-value is less than alpha, then we conclude what? That we reject the null hypothesis, and we say that that particular variable really affect the variance on my data, so that is a factor that is important. So there are no the means are not equal. Let's do that. So for the program used, that is the sample, there are no differences. So the program itself do not really affect my data. Okay, what else? What about the college that the students belong to? This affects which college is better. We don't know. We only say that they are not equal. The college really affects the columns. Being a business or engineer or arts and science really affect the variation on my GMAT scores. And what about the interaction between the college and the program used? Let's see. No, there are no real significant differences in the interaction itself. So we say that the only factor that really affect my GMAT is the school that the students belongs. The sample or the program didn't affect neither the interaction between the school and the program used. And that's it. That is the conclusion. And you need to know how to make the interpretation of this value, how this value come from, and what this p-value mean, and what is your conclusion at the end of the analysis. That is what is important in this chapter.